Hello, this is Sigma Bob. In this video, I will be discussing problem 15 from the AMC 10 2024A. We will carefully examine the problem statement, identify the key idea required for its solution, and work through the steps in a clear and systematic way. Let's get started. Here is problem 15 from the AMC 10 2024A. Let m be the greatest integer such that both m plus 1213 and m plus 3773 are perfect squares. What is the units digit of m? Make the two perfect squares as close together as possible and use the fact that they must have the same parity. Pause the video here if you'd like time to solve the problem yourself. Now let's go through the solution. Since m plus 1213 and m plus 3773 are both perfect squares, their difference must be 2560. To make m as large as possible, we want these two squares themselves to be as close together as possible. They cannot be consecutive squares because consecutive squares always have opposite parity, while m plus 1213 and m plus 3773 clearly have the same parity. Therefore, the closest they can be is with exactly one square in between them. Let that middle square be x squared. Then the smaller square must be x minus 1 squared, and the larger square must be x plus 1 squared. Since the difference between these two squares is 2560, we have 2560 equals x plus 1 squared minus x minus 1 squared. Expanding and simplifying, the x squared and constant terms cancel, leaving 2560 equals 4x, so x equals 640. Therefore, the two squares are 639 and 641. Notice that both 639 and 641 end in 9 and 1 respectively, so both squares end in 1. Since m equals 639 squared minus 1213 equals 641 squared minus 3773, and both 1213 and 3773 end in 3, the unit digit of m is obtained from subtracting 3 from 1, which gives 8. Therefore, the unit digit of m is 8. The final answer is choice E, 8.